Right, so let's look at question number 2. So we have a 300 ohm resistor connected in series with a 5 microfarad capacitor. The voltage across the resistor is given by this expression here where VR is in volts and T is in seconds. So we have to write an equation for the current in the circuit. So for this one here, we are going to try to create an equation that is similar to this basically to this expression given here lah, okay? So the only thing that we need to find here is the value of I naught. So I naught can actually be calculated using the equation V across the resistor divided by the resistor, okay? So this one we get from V equal to IR lah, okay? So just rearrange untuk cari I. Okay, so from there, we can then get the value of I naught to be equal to 1.2 divided by 300. So this is equal to 4 milliampere. Is it correct? Let me just double check. Yeah, okay, so that is the peak current. So put that into our equation here. We will then get something like this. So what we need to add here is telling us the unit. So where I is in ampere and T is in seconds. All right. Okay, next we have to determine the capacitive reactance. So that is 1 over omega C. So the value of omega is from the equation there. So we know that that is 2,500. This is 5 negative 6. Okay, so 1 over this whole thing. You will then get the capacitive reactance to be equal to 80 ohm lah. Right? Okay, lastly, we have to determine the equation for the voltage across the capacitor. So for this one, you can either keep it in cos ataupun kamu mau change it to sine pun boleh. Okay, so I would prefer to keep it in to use sine sebab that is the general equation that I always use in our notes lah. Okay, so this is gonna be sine omega t. Okay, but in order for us to do this, we have to know whether the voltage across the capacitor lag ataupun leads the current. Okay, so if we refer to our notes here for the RC series circuit, we can see that the voltage across the capacitor will lag the current by pi over 2 radian by 90 degrees. So dia lag lah, kiranya current lead the voltage across the capacitor by 90 degree. Okay, so what I'm gonna do here is we are gonna keep that in mind. We're gonna keep that in mind, all right? So we know that VC lags I by 90 degree ataupun by pi over 2 radian, all right? So what I'm gonna do is I'm gonna try to find the peak voltage across the capacitor. That is basically just I naught darab dengan the capacitive reactance. This is sine omega t masih lah, okay? So this will then be 4 milli. Capacitive reactance is 80 ohm sine 2500 t. Okay, I'll explain to you later kenapa dia masih lagi 2500 t di sini, okay? So this will give you 0.32 sine 2500 t. So this is the voltage across the capacitor lah. Don't forget to state the unit, where VC in volt, T in second. Okay, so ini adalah solution kalau kita guna sine. Sekarang ni macam mana kalau kita guna cos, okay? So kalau kita guna cosine, dia tidak boleh letak as cos 2500t terus. Okay, kenapa salah? Sebab sekarang ni kita tahu the voltage across the capacitor will lag the current by 90 degree. So, kita perlu ada tambah something di sini untuk bagi tahu yang dia lag the current by 90 degree. Okay? So, apa yang kita akan buat is, in maths, we know that it should be written as 0.32 cos 2,500 minus pi over 2. Okay? So, kenapa sekarang ni kita ada minus pi over 2 di sini? This is telling us that the voltage across the capacitor lag by pi over 2 radian. Okay? Ini kalau kita guna cos. Okay? Sebab sekarang cos dengan sine graph adalah berbeza. So, in order for this to be equal to this equation here, we have to add this pi over 2 radian here lah. Okay? Right. Yeah, so that is basically that. So, kenapa kita guna sine and then directly di sini? Sebab dia akan bagi tahu yang basically sine 2,500 ini sudah bagi tahu kita yang di voltage across the capacitor lags the current by 90 degree. Alright? Okay, so that is the solution for question number 2.